In this video, we're going to be taking a look at getting a production instance of Graphene up and running in a way which is reliable and sustainable. We're also going to be taking a look at a couple different approaches for doing that and maybe some of the advantages and disadvantages of each method. So to start off, we're just going to start with a basic web server, right? And in order to have a web server, we need to have some hardware associated with the web server. Now, this may be virtual hardware or physical hardware, but in general, we need something like CPU and memory to make this run. On top of that, we're going to stick an operating system. In this case, we're going to go with Linux, but there's no reason that Graphene couldn't run on something like Microsoft Windows if set up properly. On top of that, we're going to use a web server. Again, in this case, we're using Apache, but we could use something like Nginx or IIS, again, if set up and configured correctly. On top of that, we have our application, in this case, Graphene. And Graphene, in order to function, needs a database. We use MySQL, and it also needs a local file storage. And this is a reasonably standard way to stand up a web server and stand up a web application on the internet. This example is typically called the LAMP stack, where LAMP stands for Linux, Apache, MySQL, and PHP, where Graphene is written more or less in PHP. And it's reasonably straightforward and relatively simple to manage. So where this starts to break down, however, is when we have load that exceeds our ability for our hardware to really handle. And so what we do for that, typically, if we're doing something called vertical scaling, is we just say, okay, no big deal, let's just throw some more hardware at it. And of course, that speeds it right back up, and we're good to go. Now, this technique is a little bit, has some downsides. Obviously, as we continue to add more and more and more hardware to this thing, we can do that. But typically, the internet is kind of cyclical. And so what we end up with is a situation where the vast majority of the time, we're not actually using a lot of that CPU and a lot of that memory that we've added. So it's kind of a waste of resources. And it's also hard to scale up and down dynamically to meet our current needs. So while this is a totally valid approach, a vertical scaling approach, we're going to kind of abandon it for the time being and look at a different way of doing this. So in this example, we've got a web server here, not unlike the web server we had before, and we're going to throw in a second web server. Okay, so now we're looking at something called horizontal scaling, and it looks obviously horizontal because we're adding things next to each other. And the idea with horizontal scaling is we throw a load balancer out front, and we have all the traffic come into the load balancer, and then the load balancer evenly distributes the traffic between web server 1 and web server 2. Now, this is not great for a number of reasons. One, depending on which server you go to, you're actually talking to a different database and you're looking at different files, which if this runs for more than a few minutes, you could very easily end up with these two applications getting totally out of sync. And so there are some techniques that you could use to try to do database replication across these databases, where you're trying to push updates and pull updates as they're made between those two servers and try to synchronize those two file storage things. But that's really not an optimal solution here, especially as we continue to scale out horizontally and add more and more web servers. So a better idea is to just pull the database and the file storage stuff out of your web servers and put them outside, abstractly separated from that thing. And that works pretty well because now Graphene, the application here, is able to talk to the database and is able to talk to the file storage. And really, it's talking to the same database and the same file storage no matter which web server that we're on. And that works pretty well. And we, of course, can continue to scale this thing up as needed as we keep going. Although you'll notice here that we've actually got a lot of servers in this case. So if you're keeping score, we've got a dedicated database server, at least one. We've got a dedicated file storage server. We've got a dedicated load balancer server. And then we've got n number of dedicated web servers. And we're not quite done yet because we really need yet another server to kind of manage all of this stuff. Because if you think about it here, we're talking about ideally auto scaling, where somebody's looking at the load balancer, seeing what the load looks like, and maybe adding and removing web servers on the fly dynamically, depending on what the particular need is at that particular time. Also, Graphene, you'll notice that even though we were able to pull our database outside of the web servers and our file storage outside of the web servers, we actually do have a copy of Graphene running on every single one of those web servers. And so if we push an update to Graphene, we actually need to push an update to every single one of those web servers. Otherwise, we have a synchronization issue. And so let's just create a block over here on the left-hand side. This is this purple block. And this thing is going to, in theory, somehow manage all of our deployments in terms of keeping our Graphene applications in sync. And it's also going to auto-scale us up and down depending on our particular load. Now, you could do this all in-house with existing servers. You need 1, 2, 3, 4, 5, 6, possibly more servers, depending on what your particular needs look like. Or there are systems out there which allow us to do this stuff in the cloud and a lot easier. So I'm not necessarily saying that AWS is the only way to do this, but it just so happens that Amazon Web Services has a whole bunch of services which actually meet all of these needs exactly as we have them here. So starting at the top, we have Amazon RDS, which is their relational database server, and that allows us to stand up something like a dedicated MySQL database as a service that lives outside of our actual web servers. They also have Amazon EFS, which stands for their Elastic File System, and that allows us to have our file storage outside of our web servers. We also have Amazon EC2, which is the servers themselves. We have our load balancer, which is our Elastic Load Balancer. And then we have this thing over here on the left-hand side called Elastic Beanstalk. And that's what's going to manage our scaling. That's what's going to manage our deployments. And that's what's going to make sure all of this stuff kind of stays in sync. So AWS is a great way to do this horizontal scaling thing. It works very well. That's actually what Binghamton uses for its deployment. But of course, it's not the only way that you could do this. It is recommended, however, that if you have more than a basic implementation of Graphene in a production environment, something like horizontal scaling is probably your best bet, as vertical scaling may not scale appropriately or may not size appropriately for your organization depending on your dynamic needs. And that's pretty much it. Thanks.